Alrighty, I'd like to welcome everybody to our talk today. We're off in the distant reaches of the show hall, it seems. I want to thank you all for coming. You guys are the lucky ones. We have a really good session today. I hope you'll agree with that when all is said and done. But essentially what we're going to be showing and talking about is how we built the supply chain application that was shown in the day one keynote demo with Bob Muglia. How many people were at that day one keynote? Great, super. So you guys saw where Red Prairie came up, and they did a one-button recall. And he talked about how they use the cloud services to do that. We're going to take a look under the hood. Okay? And just some quick introductions. My name is Jack Greenfield. I'm a senior director with the Platform Architecture Enterprise team in DPE. This is Wade Wegner, architect with DPE Field in Chicago area. All right, so to get started, you may remember that the scenario described in the keynote involved a recall where product had been manufactured and shipped and distributed to various warehouses and/or retailers, and then a defect was discovered with the product, and the product had to be recalled. That's a pretty familiar scenario these days. A lot of somewhat scary product recalls have taken place. I'm sure we've all seen them happen. It turns out that product recall is a very challenging kind of application to build because it really requires orchestration of activities among a number of different enterprises. And the way it works today, as Sean explained on stage when he was talking with Bob, a lot of custom infrastructure has to be developed. That is to say, a lot of custom networking infrastructure, hardware and software, custom code has to be written in order to provide the connectivity among all the participants in the supply chain, and in order to do identity mapping and enable the exchange of messages to flow freely and securely. So it turns out that this is very cost prohibitive. It's very expensive. And it is, in fact, a distraction from the business of a company like Red Prairie that really wants to be focused on the supply chain scenarios. They don't want to be an infrastructure vendor, but that's what they find themselves having to take care of and spend a lot of cycles on. What's interesting for us about this particular scenario is that it's pretty characteristic of a lot of applications in the marketplace today that cross multiple enterprises. What we find is that in many different industries, many different scenarios require this kind of distributed collaboration. And in every one of those cases, the companies involved have to invest a lot of time and effort in getting alignment at the hardware level, in terms of software, and at the business level, and getting all those pieces coordinated in order to enact a business process that spans enterprises. What we're doing with the Azure Services Platform is providing a cloud-based hub. You could think of this as an Internet Services hub. We talk about the Internet Services bus. It's more than just a bus. It's a bus plus authentication and access control mechanisms, cloud-based storage, and cloud-based workflow, as you've heard about in the keynotes. And the collection of these services together enables us to dramatically simplify the architectures of these kinds of multi-enterprise business applications. With that introduction, I'm going to give you a teaser and then turn this talk over to Wade. The teaser is that after we've looked under the hood at how the app was built, we're going to talk a little bit more about this class of applications and how we think cloud-based services are going to change the landscape for B2B. There's a lot to say about that. And we're also going to show you also some patterns that we implemented and some of the architectural pieces behind it. So before we get started on looking under the hood, what we're going to do is quickly have a peek at the workflow so that you'll have a feeling for how that looks. There's actually two main workflows in the application. This is the first one. This is the recall initiation workflow. And in this workflow, you have Contoso at the top initiating the recall by interacting with the service bus in the cloud. What that does, and I'll show you in a little bit how we step through this, that actually kicks off this workflow in the right-hand columm which involves a step of getting connection details for the different partners. That information is pulled out of SQL Data Services in the cloud. That information is then used by subsequent workflow steps to actually iterate through all the partners that have to be notified about the recall. For each partner, the notification of the recall is issued via the relay. The partner receives the service and then responds to acknowledge their receipt of it. And that loop continues, logging the responses until all the partners have been contacted. Now, the logging of the responses in the cloud-based store is very important for the purposes of regulatory compliance. It's very important that in a recall scenario, there is traceability to know who was contacted, who actually received the recall message. There can be legal and financial consequences for companies that don't comply with a recall or don't comply in sufficient time. And so being able to prove that you did or didn't receive the message can actually have some significant consequences. The second workflow is a very simple one, but an interesting one because it's asynchronous. Essentially, what happens is after each of the partners involved in the recall receives the recall notice and acknowledges receipt, they then proceed to actually enact the recall. That is, they go put product on hold, or they pull things off shelves, or they stop sales at point of sale. As these actions are taking, they report their actions. They do that by sending messages up via the service bus into a cloud-based workflow, which then logs those actions, again, for the purposes of regulatory compliance and auditing. Okay? What we'll do after Wade has gone through some of the under-the-covers bits and pieces, we'll actually walk you through this workflow. Or actually, it might make sense to do that now that I've talked about it.
Okay.
Yeah, so I'm going to go ahead and walk you through that. So this is actually what the architecture looks like. Okay, on the right-hand side, we have the services running in the cloud, the access control services, the service bus, the workflow services, all of which comprise the .NET services. And we also have the SQL services providing data storage and access. On the left-hand side, we have stuff running on-premise. What you see at the top is Contoso, the organization that initiates the recall. You see Red Prairie with on-premises services running. And then you see AdventureWorks, Fabricam, and Litware, who are the partners of Contoso, who are participating in the recall. The way this works, we start by initiating the recall in a web application in Contoso. The web application communicates with the one-button recall service, which authenticates itself to the access control services running in the cloud via X509 certificates. Having authenticated itself, it's now able to send a message via the service bus relay to the workflow, which is running on-premise at Red Prairie. A service host there receives the message and then authenticates itself with the SQL services using ID and password and logs the fact that a recall has been initiated. The next thing that happens is that the service host kicks off the workflow, which is now going to authenticate itself again with SQL services and record the fact that the workflow has started to run. It will then authenticate itself, this time using card space because it has a different authentication requirement here, via access control in order to send a message to each of the participants. The messages are then sent via the service bus and received by each of those recipients. Then what happens is that each recipient in turn has to acknowledge receipt, as we saw. So how do they do that? Well, they authenticate themselves back to access control services using their own X509 certs, and they then send via the relay an acknowledgement message, which is then stored in the SQL services in the cloud. And that happens for each of those partners as they're contacted and respond. Okay? And at that point, we then get into closing out this process where the console essentially logs the fact that the process is complete. Okay, and at this point, I'm going to cut over to Wade, and we're going to look at how it works. Then we'll come back and look at some of the patterns that were used.
Hello. So how many of you guys have actually taken the time to go to the services platform site? Have you guys taken a look? Have you been able to request IDs or get access yet? So I'm going to spend a little bit of time just kind of showing the portal and how we've configured some of the access control rules. There's a lot of stuff running here to facilitate this type of an architecture. There's a certain amount that, okay. There's only a certain amount I'm going to be able to actually show, just given some time constraints. So I'm going to try to show some of the important stuff as we walk through it. As Jack mentioned, we're making use of almost all of the services in the services platform, including the SQL data services. That's where we log and store most of the information as it goes across and as partners communicate back and forth. We use the access control service to actually provide federated claims so that each of our partners can actually communicate with each other. And the service bus performs relay mechanisms so that we don't have to build the point-to-point custom infrastructure for each of these partners to communicate. And I'll show a little bit about this as we go along. So here in the services platform, what I wanted to show you is how we configure the on-premises service so that it can actually communicate with partners and relay things. So when you log in, so our solution is Miba 8 services. So you have the ability to define your solution name however you'd like. You can see this was our 8th iteration of defining the solutions. We'll step in here to access control service, and this is where we can actually go and take a look at how we have our service bus configured. So when I select the solution, I can take a look at the service bus. You can also define access control rules for workflow. I'm going to go ahead and take a look at the service bus and show you how we have our access control rules set up. So the idea here is that when someone's communicating, or excuse me, when someone is authenticating against the access control services, basically they provide an input claim. And so that input claim can be a number of things. In this case, what we've done is we've taken the idea of having an input claim that is a username password. So for each one of these services, they have a username and password associated with them. When they pass in that claim of the username, they get back an output claim. That output claim defines what they're able to do across the service bus. So you can see for each one of our different services, or for each one of our different actors or partners within it, they have a number of different actions, one of which is send and one is listen. Now these are two types of output claims that are actually set up and facilitate the interaction across the service bus. So an action of send indicates that this partner or this service can send a message across the service bus into an endpoint. A listen would indicate that they can actually listen at an endpoint and actually receive messages in. So here we've configured how these solutions map the input claims to the output claims. Additionally, let me step back, and I'm going to show you how Jack had also mentioned that one way to authenticate it would also be to utilize a certificate. And so our partners have also set up solution credentials that allow them to utilize a certificate to actually control that interaction. So you can see here, I won't go through the SDKs that are provided with the .NET Services SDK have a lot of great walkthroughs in which that shows you how to generate the certificate, register the certificate, and then actually upload and register the certificate within the access control service. So I encourage you to take a look at that. But here what we've done is we've actually generated a certificate and actually uploaded it within the access control service. Similarly, when you look at Cert Manager locally, you'll see that I have corresponding certificates here as well. So those certificates are actually able then to, are used as an input claim in order to get some sort of an output claim. So that's how we've set up our access control. And if I step back to my solution, you'll see that up here I have a number of different solutions set up here. And each one of these different solutions represents a different partner or various service within it. So for instance, our Miba services represents the Red Prairie on-premise services that are used to run the workflows that actually facilitate this business process. Additionally, we have Contoso. In our scenario, Contoso was the partner that actually initiated the recall. So Contoso has a set of access control rules that allows them to actually send a recall message to the Red Prairie software, which then goes through and actually generates this recall process. And then additionally, we have 3 partners defined: AdventureWorks, Fabricam, and Litware. And each of these partners they may have a different role within the recall process, but they also need to have their own sets of credentials configured within access control so that they can interact within this business process. So this is the portal, and this is how we've gone about configuring it. Now, what I'm going to end up showing you is within our, let me go to full screen. So what I'm going to demonstrate is we have a series of services that I'm going to start up and run. Each of these services basically end up becoming endpoints on the service bus. And so what we have here is we have a set of, we have a factory that we use to actually create that service host. So you can see here, what we do is we generate it, and I'll go through and show a little bit more of the details here. But we end up creating this service host. How many of you are familiar with WCF? We have a lot of experience. So one of the great things to really be cognizant of is that the interactions with the service bus, all your skills, all your knowledge of WCF still apply. So it's a very similar paradigm. Basically, you're utilizing the service bus to get additional functionality on top of WCF that really helps make these interactions between different partners easier. And so what we're doing here is we have to first set up a series of credentials. These credentials are going to be the credentials that we use against access control services so that we can actually run this endpoint within the service bus. And so the first step is to actually create the transport client endpoint behavior. And here we've done is we've created a little helper function that allows us to get the behavior. And a lot of this is driven off of configuration files. And essentially what we do is we come through and we take a look to see how we have our behavior configured within the config file. There's a number of ways in which you can authenticate. Here you'll see that we show a card space interaction, a username, password, and then also the X509 certificate. And so based on the way in which this service is configured, we can actually then grab the appropriate behavior and associate, for a username password, the username password, if it's a certificate, what that certificate name is, and so forth, and pass that back so that we can actually construct our factory that we use to communicate. Next, you'll see here what we do is we have a service registry setting. Now, let me take a moment to explain what this is. So the service registry, basically it's a mechanism whereby you can make your service discoverable. So when you add an additional behavior for the service registry, it'll actually add that endpoint in such a way that you can actually query off of it and actually take a look. And once I start the services, I'll show you how this looks. But the service registry is another behavior that we end up adding to the endpoint so that it becomes a discoverable endpoint within the service bus. Next, we have to construct what the URI is. And so the interactions with the service bus uses a service bus protocol. And then the way in which we've gone about it is there's a enum value that allows us to grab the service bus environment and specify what the URL is. So that ends up being something to the effect of servicebus.microsoft.com. And then we attach the username, which defines our particular solution. So Amoeba 8 services would be an example. And then we also end up passing along with that actual service name. So the idea here is that what we're doing is we're constructing a specific unique endpoint that gets published to the service bus so that it ends up becoming an endpoint on the service bus. The last thing we do then is we actually generate the service host and go ahead and add the endpoints and return this. So in the end, what we're doing here is we're generating our service host, and then we're going to actually run it. So let me go ahead and show you what that looks like. So what I've done here is just to make it easier, I'm using PowerShell, and I've got a series of scripts. And so what these scripts are doing is they're actually starting up our consoles. Now, for the keynote, we didn't use console applications. It's a little easier when describing what's going on to have them running in console applications for the keynote. You can imagine these would be Windows services, and that's what we ended up using. But this makes it a little bit easier to talk to what each of these endpoints are doing. So what I did here is I started up our on-premises services. So these services would represent services that run at Red Prairie. So these services would run our workflow and basically orchestrate the business process and this recall that we're trying to orchestrate. And then here we've got our partner services. Start partners. So these partner services would represent a service running at a partner. So you can imagine most partners, when they're doing a recall or whatever type of process you're trying to do here, would have some sort of back-end process, some line of business application that they'd use to facilitate this. These services are just representing whatever that application is. So it provides a way for us to send a message to them and then also receive messages back. And so basically I've started these. Now all of these services now are started. They are endpoints on the service bus. And before I had mentioned the service registry, let me just show you what I meant by that. So the service registry shows publicly listed services. And so what I did is I refreshed. Now that I've started my services, because I have that service registry setting, it's actually made them publishable. And here you can see, just via RSS, I'm actually able to come here and query and take a look at the fact that these services are running. If I were to go to a partner service like Contoso, let me see if it's refreshed. I just typed try Litware. There we go. So here you can see Litware has a warehouse service running as well. So basically it's discoverable. Ways in which you can use this are, for instance, I'm not going to demonstrate this here, but some functionality we built was a mechanism whereby a partner could take a look to see all the various partners that are currently online and have endpoints published into the service bus. So there's a number of ways in which you could utilize this information to provide some sort of functionality that might be useful. All right, so getting rid of this. So let's see, so everything started. So what I'm going to do is go ahead and initiate a recall. So here what we have is, this is a piece of software that runs, currently it's a piece of Red Prairie software that runs. I apologize about the formatting for the keynote. We designed everything for 1280 by 720. This resolution doesn't quite get it. So what I'm going to do here is I'm going to initiate the recall. And this is the same thing we did in the keynote. I'm just going to show you a little bit about what's happening. So there has been a defect, and I'm going to go ahead and recall it. So what's happening right now is when I click recall, it's actually taking this message and it's going to publish it through the service bus. That service bus, if you remember when we walked through what the architecture for this solution is, when it gets published to the service bus, it's going to get relayed to the Red Prairie on-premise workflow. That workflow is going to run and figure out exactly what it needs to do in order to facilitate that recall. And then it's going to pull information about each of the partners that we have stored in SQL data services, figure out what the specific endpoints for those partners are, and then send the messages to those partners. And so there's a bunch of logging and various other things that occurs along the way so that we can provide some compliance reporting. But that's generally what happens. So as part of this project, the wrong thing, what we also did, it's very difficult to describe what's happening. So you see here I have an end user application and I've submitted something, but it doesn't really show what's going on underneath the covers. It's very difficult to show the plumbing sometimes. So what we did is we tried to create a console application to help really facilitate this. And I'll show you a couple of pieces here and what this console application does. So this shows a number of different pieces. You can see here the access control service monitor. What this is it's very similar to the information that's showed within the portal, and it will take a little bit to query, but I'll go ahead and change it. But basically you can see we have sets of claims that are defined for this account. So you have the ability to specify usernames, actions, and various other things. And then we also have our rules. So these rules are very similar to what I showed you in the portal that define how our services can, or what actions our services can take based on the claim that they make. So you can see here they have the ability to send and listen and so forth. And then basically this allows you to pull and iterate. The thing to note about the access control services is there's a set of APIs that you can program against in which you can pull most of this information. So you can use the portal to define access control rules, to look at access control rules, but you can also write your own applications. So for instance, you may have a partner that you want to include within some sort of process, and you wouldn't want to either have to manually go to the portal and add them, or you may not want your partner to do that. So you could write an application that's able to actually utilize the APIs to actually create the partner rules within it. So that API provides a lot of functionality, and here we're just iterating across it. We also have a SQL data service monitor. And what this is, and I'm not going to get too much into the architecture of SQL data services, but basically you have authorities, you have containers, and entities. And so what we've done here is we have the ability to query against an authority and actually look at our container and look at all the various entities that are within that container. So you can see we have recall shipments, we have partner types, we have recall history. What I'm going to show you is what we've done here is we've created a recall. And if you take a look at some of the information that we've entered here, now note you'll see that recalled on, that's actually because it's set for Greenwich Standard, or it's not set for the specific time zone. But if you look at the timestamp here, 24, it was about 4 minutes ago that I started the recall. You can see that what we've done is we've generated a new recall ID of 60012. And this recall has then created a whole bunch of additional information. And so what we can see if we take a look at some of our services, you can see here within our workflow service, that's our recall. That's the same thing I just showed within the SQL data services container. And then additionally, each of our partners, what we've done is, and this is basically what we have a number of things that automatically respond just to show some sort of a recall process and how that might be facilitated. And you can see here what they've done is each of these partners have said, all right, I received this recall for this lot, for this product, and I'm going to go ahead and start initiating the recall. First, I'm going to acknowledge the fact that I received the notification, and then I'm going to go through and actually do what I need to do in order to pull it. And so It may be a little bit difficult to represent here, but you can see here the process has been initiated, and then here all items have been recalled, and here's the recall quantity. And so this information is that asynchronous workflow that takes place in which the partner is able to then send information back into back via the service bus into SQL Data Services, and then now Contoso or Red Prairie has the ability to take a look at that information, generate some compliance reporting, and so forth. So really, that's it. So I mean, those are some of the basic components that we used, and I think I'll switch it back to Jack.
That's very cool. Thanks for showing that, Wade. All right. So what we now want to do is show you guys some patterns that we used, and what we'll do here is I'll walk you through the pattern, and maybe Wade can say a couple of words for each pattern as to how we used it. So the first pattern is the basic message relay. This is really what the Internet Service Bus is for. The basic idea behind the message relay is that instead of actually having to have all the connectivity information to contact a remote partner and all the authentication on a point-to-point basis, essentially you can use the cloud to relay through. So effectively, I send the message to the cloud, to the .NET services in the cloud, and that message is then relayed to the ultimate recipient. I essentially have a level of indirection. This level of indirection makes it easy for me to find that partner and to authenticate that I can actually send that partner a message which they're going to be willing to receive. And all of that is done in a very simple manner via configuration. So Wade, how did we use this particular pattern?
So this pattern, when we broadcast that message, we're essentially using the service bus to relay this information. And so to come back to why the service bus is useful, right now a message relay pattern, this is nothing new, but in order to support this type of a pattern, oftentimes you need to spend a lot of time building out that infrastructure, whether it might be some sort of VPN connectivity so that you can actually send this message securely back and forth. It might include some sort of devices or hardware to facilitate that. Basically, here you're able to utilize the service bus so that the recipient, in this case Fabricam, is able to publish their endpoint on the service bus. And then the sender, Contoso, is able to communicate to the service bus through that published endpoint to facilitate the message relay.
Very cool. All right, let's have a look at another pattern. This is store and forward. Again, it's a familiar SOA pattern, but again, it's being implemented in the cloud, which is something of a twist. So what happens here is that Contoso sends a message. That message is actually stored in the cloud in SQL Data Services. Then that message is forwarded to all connected recipients, AdventureWorks and Fabricam. Now, what's interesting is that later on, Litware connects in. They weren't connected initially. Now, when they connect in, we recognize that they're connected, pull that information and say, you need these messages. We're going to forward this one that's in the queue waiting for you. Okay, so Wade, how do we use this particular pattern?
So in the recall process shown here, this prototype didn't, or this recall application didn't use this particular pattern. However, when we were really trying to figure out how do we facilitate this type of interaction, we explored a number of different scenarios, including goods requests as well. So that was so we had a goods recall and a goods request. The goods request, we built and utilized this pattern because we wanted to show that if a partner was not currently did not currently have an endpoint on the service bus, we could then add them back into the process, and with some sort of long-running workflow, we were still able to relay that message to them.
Very cool. Okay, the next pattern is content-based routing. Again, a familiar SOA pattern in which Contoso sends messages containing specific content, labeled A, B, and C. Those messages are then stored away in SQL Data Services. Then each of the partners in turn, as they connect in, requests messages with a certain type of information in them. Here, AdventureWorks is requesting type A, and they receive the messages sent by Contoso with type A information. Fabricam is requesting type B and receiving those messages, and Litware is requesting messages with information type C, and they're getting that back. Now, how did we use this one?
So this pattern allows each of our partners, so the case Fabricam or Litware and so forth, if they have a different structure to the message, if they're expecting different information back, it gives them the ability to actually request that particular type of message. Now, again, in this scenario, we didn't make use of this pattern, but it was another thing that we wanted to prototype and explore and make sure that we could support this type of pattern and scenario utilizing the Azure Services Platform.
Cool. Great. All right, another one, scatter-gather. Again, another familiar SOA-based pattern, this time using the cloud again. So here, Contoso sends a message that's going to actually be distributed out to multiple recipients, AdventureWorks, Fabricam, and Litware. And the interesting twist here is that each of them is going to respond, and we're going to aggregate those responses and send it back as a single message to Contoso. And what's our story here, Wade?
So it's going to sound a little repetitive. Again, the keynote presentation and the goods recall didn't utilize this pattern. But the important thing to emphasize is we wanted to show and explore, what were the possibilities using this platform? Because each one of these types of business processes are going to have different requirements and would need to have different patterns in order to facilitate it. And so in this case, this was another attempt to show that utilizing the services platform, we were capable of utilizing this pattern.
That's a great point, that we actually prototyped a number of different patterns and then selected the appropriate pattern
Correct.
for that particular scenario. The scenario that we demoed was just one of a number that we built. Okay, data transformation. This is also quite familiar. Here we have data sent in a message. The payload is in format X. And through data transformation, we're able to forward that message in different formats to the recipients. Format A, Format B, or Format C. And again, this is something I'm guessing that we prototype but didn't include in
Yes, but there's an interesting thing
demo
here to note, and we haven't talked about it as much, but this transformation requires some sort of a host. It requires something to actually make that transformation. So the service bus itself is a relay. Access control services provides the ability to make a claim and receive an output claim. What this pattern shows is that you can utilize workflow services, so that when you send the message into the .NET services, you can utilize workflow services to take that message that's coming in, provide some sort of a transformation on it, maybe transform it from one format, one type of XSD or schema into another format before you actually then relay it to the endpoint. So that's the important thing to note within this pattern.
Cool. Okay, our last pattern here is claims-based authentication, and this one I actually know we did use in our keynote demo. Here we have a request for a security token made against the access control services. And by virtue of providing the right credentials, the right form of authentication, we get back a SAML token. This token can then be used in sending a message via the services relay to a partner. That token is checked against the claims that we're making, which the partner needs to see in order to trust the message. That token validates, and therefore the claim is placed by the secure token server into the message so that we can then assert that we have that claim when we send the message to AdventureWorks and they can trust it. Okay. Another related pattern here, which is federated trust, is one in which instead of using the cloud-based secure token server, we're using an on-premise custom secure token server. That's the ID provider secure token server in the lower right-hand corner. It's actually federated with Active Directory, and it has a trust relationship with the access control services in the cloud. Here, we make our request for a security token from Active Directory. That local provider then gives us the SAML token, which we then return for use in authenticating a message which we're going to send. Again, the same kind of check is made because that is a valid security token via the trust relationship between these servers. We can now make the claim that this message can be sent over to Contoso. So with these two patterns, Wade, how did we make use of one or both in our...
So we made heavy use of the claims-based. It's interesting, when coming to the federated trust, this was something we did prototype, and there's a lot of different talks about how you might utilize various things. So Geneva Server, which is something that was announced here, is one. It's a server product whereby you can actually have the Geneva Server is an STS that will communicate and coordinate with Active Directory to provide this type of a service for federated trust. So we explored a number of those ways. When it came to the scenario, we still used the claims-based. We didn't use federated identity or federated trust for a number of reasons, one of which was just simplicity and being able to highlight some things. But definitely made heavy use of the claims-based.
Very cool. All right. A few guidelines also very familiar guidelines from SOA were brought to bear here. Decoupling of data and process. So as you saw, we had a workflow that embodied the process. The data that was used to support that was decoupled and stored separately. We designed for stateless interactions, so as you saw, the various parties are able to receive messages. There's no state that's suspended in a session of any kind. In fact, it allows us to have completely asynchronous interaction. Again, we had long-running transactions managed by intermediaries. So as you saw, we were able to sort of distribute the processing across multiple workflow steps with asynchronous replies in order to complete the entire process. There was location transparency in that Contoso knew nothing about where any of these partners actually resided or what their physical addresses might be. That was completely hidden via the relay. Federated identity, as Wade points out, it wasn't so much that we used federated identity as much as we used claims-based authentication, was another sort of key guideline that we followed here. And then lastly was relay versus message store. We were able to take good advantage of the relay pattern in building this demo. What we also wanted to do here was show a little bit more of the kinds of scenarios to which this kind of architecture can apply. So let's take a look at another workflow. This is another one of the ones that we built out but didn't actually show in the keynote. It's called Goods Request. And again, this is one where, partnering with Red Prairie, we identified a workflow that would be a good candidate for this kind of application. And we'll bring that guy up here.
1 second while I find it, if I have it. So sadly, I do not have that workflow on this machine at this time. So
all right, well, you can imagine that it was a very interesting workflow. Sorry about that. What I'm going to do is, since we're not going to take time doing that, I'll jump right to this next point, which is that the goods recall and the goods request scenarios are just many of a number of interesting scenarios that we work through with Red Prairie in exploring these technologies and discussing which ones would be best suited to being demonstrated in the keynote. And really the broader story here is that the project was not just about the keynote. It was really about exploring a variety of scenarios and applying the cloud technologies to understand the basic architectures that should support these kinds of applications. These are scenarios that are part of what we call supply chain orchestration. It turns out that supply chain orchestration is just one of many categories of scenarios that appear in the supply chain industry. And our partner, Red Prairie, as one of the leaders in the industry, works with a rich palette of scenarios. And it's very powerful to sort of look at the set of different scenarios that can be implemented using cloud-based technologies from across the supply chain industry. What's interesting, though, is that we can go beyond the supply chain industry. This concept of a multi-enterprise business application can be used, and a lot of these architectural patterns and techniques can be used with the cloud service technologies to address a number of other industries, such as commerce and markets, auction and reverse auction, industry data exchange, product lifecycle management, medical records exchange, and telecommunications. Now, if you've been around for a while, you probably remember back in the 90s, there was a real emphasis toward B2B applications based on protocols like EBXML and RosettaNet and Commerce One and UNCFACT. And it turns out that some headway was made, some good progress was made, but it didn't really take hold as much as everyone had hoped it would. And we now realize one of the reasons is that the cost of building out all the infrastructure to actually enable those kinds of collaborations was prohibitive. So this has given us a lot of excitement, because as we look forward, we think the industry is going to see a renaissance, a resurgence of these kinds of B2B applications with much cheaper, much simpler infrastructure, making it a much lower barrier to entry to get involved in this kind of thing. And so this MEBA project, Multi-Enterprise Business Application Project, has really been, and will continue to be, we're going to run it through the end of the fiscal year next June, all about fleshing out some of these scenarios and understanding how best to implement them. One of our next steps is going to be applying models. A lot of the business processes and workflows can be nicely modeled, and the endpoints can be automatically defined and generated. So we're hopeful that we'll be able to demonstrate some model-driven business process orchestration using these cloud technologies as we get toward the end of the year. In order to do that, we're going to need some additional services. What you see here is an architecture diagram that shows how we've layered some services on top of the Azure Services Platform. So the Azure Services Platform is providing the .NET Services Stack and the SQL Data Services Stack, which we're using heavily. On top of that, we built, for the prototyping work that we've done so far, a framework, which we call the MIBA framework. Wade mentioned the channel factory that enabled us via configuration to get the right endpoint definitions. We also have a data access layer service, some events and notifications infrastructure, a roles and privileges service, and some groups and memberships support in this framework. What we haven't done yet, but plan to do in the rest of the project as we go toward the end of the year, is this layer above. This is the model-driven layer that will enable us to upload models of the business processes that we want to automate and help to orchestrate their execution. So here we have 4 service stacks. We have a party management service stack used to manage the definition of parties, bind them to specific application roles, establish their SLAs with the host of the distributed business process, and onboard them, provision them. There's a service choreography stack, which is used to manage the actual execution of the business process, including some of the data transformation pieces. There's a business process service stack, which is used to store and manage the definition of the service and make it visible to all the participants, and which also defines the SLAs that are party to party within the business process. So how does one partner in a supply chain establish an SLA with another partner, not with the broker or the manager of the supply chain, but with another partner across that supply chain? And how is that tracked and enforced? And then lastly, there's the market management services, which actually provision markets from the set of models, turn them on, turn them off, etc. So that's the chunk of work that we're actually working on now, going forward. So with that, I think we're pretty much ready to wrap up, although it seems to me that we might have discovered the diagram. Is that,
yes.
Is that right?
Yes.
Okay, we do have the goods recall diagram.
Redeem myself.
Yeah. All right, let's do that.
Do you want to walk through them, or I can describe them briefly.
So
in this attempt, this was one of the initial business processes that we looked at, and it was a goods request, and we identified this along with Red Prairie as a potential. Now these are very simple. We didn't end up fleshing these out to extraordinary detail, as we didn't end up utilizing this, but it at least can describe another process that we can use the services platform for. So in this case, we have a goods request that's made, followed by a bid tender process, followed by bid management, resolution, and then some confirmation and shipments. So you can see here, and we have some different parties, but in this case, AdventureWorks would initiate a goods request, and they would end up storing that request would be sent across the service bus, stored from the cloud, and in this case, use SQL Data Services as that storage. We would also extract information from SQL Data Services to define the endpoints for each of those suppliers, and then we would go ahead and we would broadcast. Now, this broadcast could be done through some type of multicast broadcast, or it could be done through some sort of specific one-to-one relay mechanism. It's not really defined here. And then additionally, we would go through and activate the bid tender process. The bid tender process would be an asynchronous process whereby each of the suppliers independently broadcast and send information that's stored within SQL Data Services, and then is used by the bid tender workflow to go through, it extracts that information, it gathers it together, and then sends it back to AdventureWorks. So if you remember, one of the patterns was scatter-gather. This would be an example of it. So requests were set out, information was sent back, we pull it together, and we send it back to AdventureWorks to fulfill that. The next step would be to for AdventureWorks then to go through and extract and look through the information that was supplied and make some decisions. So based on the information received from the suppliers, what's the best way to fulfill this goods request? So you can see how it's broken up here a little bit, and there would be some sort of workflow with some sort of business logic in there that would make that decision. Once that decision's made, that decision is then stored within our data store, and we go ahead and we send allocation details to the partners. So now what we would end up doing is initiating a workflow which would then update this fulfillment request and then go ahead and notify the supplier. So in this case, if supplier A was chosen, they would receive a message that indicated such. Additionally, suppliers B and C would receive a message that said that they were not selected. And then there would be a very simple process here whereby they acknowledge the receipt of that information. And then I believe this is the next slide. It's exactly identical. And this would be another way for then the supplier to, and I'm sorry there's no titles here, but the supplier then would send information about shipment once that process was initiated. So very simple, but it's just it's another example of a business process that you've probably all defined and built, and one in which we can support on this platform. So.
Thanks, Wade. The reason we wanted to show that process is because it's a little richer than the goods recall. There's quite a bit more going on, and we just kind of wanted to give you a flavor of the kinds of processes that we think are really sweet spots for this type of automation. So just to wrap up, we've talked a little bit about a class of applications called multi-enterprise business applications. These are applications that consist of business processes that are distributed across multiple enterprises. We're talking about how the Azure Services Platform facilitates the implementation of these kinds of applications by lowering the bar in terms of building out all the infrastructure and connectivity and identity management pieces, as well as providing hosted workflow and storage services that can be used to actually drive a lot of the business process itself. Another key point we made here is that we're partnering with Red Prairie to build proof of concepts to sort of show how these ideas actually look when implemented on the cloud services, and making those available to our partners and customers so that they can begin to understand how they can do the same kind of thing. We do intend to publish some architectural guidance which is grounded in these proof of concepts. So when we publish our patterns, and we're going to be publishing some blueprints as well to help you do this. If you haven't seen blueprints, check out our booth in the exhibit floor. It's the next generation of software factory technology. You will have the confidence that we will have actually built and run these scenarios with our partners. Also, we've described how this kind of application architecture applies to many different scenarios within supply chain and also to multiple industries. And we've talked about some of the patterns that we have harvested and some of the guidelines, and we're going to be publishing that as architectural guidance out of the project. And with that, I'd like to thank you all for coming and ask you to please fill out your evaluation and drop it off as you leave the room. And we'll take some Q&A since we've run a little long here afterwards, maybe over here in the corner. Thank you very much.
Thank you.